So in 4.7, we're going to be talking about the inverse trig functions. And remember back, we talked about inverses. The essential rule was that we were switching the x and y values to get the inverse. Now we also need to combine that with the definition of a function where the function passes the vertical line test. And one of the ways that we did that was we said if our original function passed the horizontal line test, then that means our inverse would pass the vertical line test, and therefore the inverse would be a function. Well, if we look at the sine graph, so we have y equals sine of x right here. This does not pass the horizontal line test. So that means its inverse is not a function unless we restrict the domain. And that's what you see right here. This part right here, we restricted the domain. If we restrict it like this, then that inverse would be a function because that blue portion passes the horizontal line test. So remember, for y equals sine of x, our domain was negative infinity comma infinity, and our range was -1 comma 1. Now if we restrict the domain of sine, if we restrict it where the domain is negative pi over 2 to comma pi over 2, our range would still be -1 comma 1, but we can now have this inverse also be a function. So with that restricted domain, we have the inverse sine function, and it's noted by either y equals arc sine or y equals sine with the -1 exponent of x. And remember, when talking about inverses, this is not the same as 1 over sine of x. Okay, it's notated completely different. And when we talk about the inverse sine or the arc sine of x, what we want to think about is the angle to get that value. So the arc sine of x is the angle whose sine is x. And like I said, we want to think, what angle gives me this sine value? And when we get to the next page and actually look at some examples, I'm going to come back to this. This right here is a graph of arc sine or the inverse sine, and the x values, like I was saying, when we look at the x values, we say, okay, what angle gives me that sine value? The same thing can be said about the cosine function. Okay, this is our cosine curve, and that would fail the horizontal line test. So if we restrict that domain from 0 to pi, now that function passes a horizontal line test. So we would restrict the domain for cosine to 0 comma pi, and our range is still -1 comma 1. And like I was saying with inverse sine, can be noted as arc sine. Inverse cosine, we can say arc cosine, or that -1 to note that we have the inverse. So then on the next page, we also have tangent. And again, with tangent, we're going to have to restrict the domain so that the inverse has a function, because this fails the horizontal line test. So we would restrict our tangent domain the same we restricted sine. So the domain, but we need to use parentheses because of the asymptotes at -pi/2 and pi/2, and the range would still be -infinity comma infinity. So down here is kind of a summary of the domain and range of our inverse functions. Well, you may say, well, we wrote the opposite up here, right? We restricted the original cosine function to this domain. So then we do the inverse, we switch the domain and range. So you'll notice that the inverse or arc sine and arc cosine have the same domain but different ranges. And these are the graphs of the inverse or arc functions. So inverse cosine, inverse sine, and inverse tangent. And you can see with those restrictions how now that we're talking about the inverse, these all pass the vertical line test. So in example 1 down here, it says find the exact value if possible, otherwise approximate with a calculator. So the arc sine of the square root of 3 over 2. So we, like I was saying earlier, we want to think about what angle gives us a sine value of the square root of 3 over 2. So what angle gives us a sine value of square root of 3 over 2? You may say, well, we have, multiple. We have pi over 3 and 2 pi over 3. But remember, up here we have our restrictions. We want the angle to be between negative pi and positive pi. So even though 2 pi over 3 has a sine value of square root of 3 over 2, that's outside of the range. So we only want the pi over 3 angle. Letter B, the inverse sine of 0. So on the unit circle, when is sine equal to 0? Well, sine is equal to 0 at 0 on the unit circle. Letter C, the inverse sine of 3.5. Well, 3.5 is outside our domain. Our domain for inverse sine is between negative 1 and 1. So this does not exist. It is outside the domain. Okay, then the arc cosine of negative square root of 3 over 2. So again, what angle gives us a cosine value of negative square root of 3 over 2? So on the unit circle, that's that's positive 5 pi over 6 and 7 pi over 6. However, 7 pi over 6 would be outside of our range. So it's just going to be 5 pi over 6. So equals 5 pi over 6. Then the arc tangent of 3.2. Well, 3.2 is not on our unit circle. So we're going to use the calculator. So in the calculator, second tangent of 3.2, and we get 1.2679. Make sure we are in radian mode. So 1.2, round to 4 decimal places. Round to 4 decimal places. Do we have to round up that 9? No, we don't. So it's going to stay 9. And letter F, arc cosine of negative 1. So when is cosine equal to negative 1? So when is that x value on the unit circle equal to negative 1? That is at pi. And again, pi fits in our range because right here it says less than or equal to pi. So again, knowing that unit circle is important, but then also realizing the restrictions we have on our domain and range. All right, so now on the next page, we're going to talk about the composition of functions when you have the inverse of that same function. So like the inverse sine of sine, what do you do? Or if you have the sine of inverse sine. Now, what you can do is that if we have, using what are called inverse or one-to-one properties, if we have the sine of the arc sine or inverse sine of x, that just equals x. Okay. Now, it's technically not canceling out the inverse and the sine, but you could think of it that way. And that's true with all the other functions. So the cosine of the inverse cosine of x is just going to equal x. Tangent of the inverse tangent of x is going to equal to x. Now, the other way doesn't necessarily work because if we have the inverse sine of y, we can't just say it's going to equal y because we have the restrictions on the range of the inverse sine. Now remember, order of operations say to do the inside part first of the composition, then the outside. So you'd have to find the sine of y and then do the inverse sine of that and then make sure it fits on our restrictions. So for example of that, if we have the arc sine of 3 pi over 2, again, we can't just say, oh, this is equal to, you can't just say it equals 3 pi over 2, because 3 pi over 2 is outside of the range for the inverse sine. What you would do instead is you would evaluate the sine of 3 pi over 2, which is equal to -1, and then ask ourselves, when does sine equal -1? Yeah, sine does equal -1 at 3 pi over 2, but that's outside of our restrictions right here. So instead the answer would be -pi over 2. So you do need to be careful of that when you are taking the inverse trig function of that trig function of an angle. But in the other direction, so like sine of inverse sine of 1/2, okay, well that's just going to be 1/2. So let's look at these examples here. So example 2, it's the cosine of the inverse cosine of the square root of 2 over 2. Now, you can do it one step at a time. You can say, okay, when is the cosine, when is cosine square root of 2 over 2? Well, that's at pi over 4. So this becomes the cosine of pi over 4, because those equal the same thing. And the cosine of pi over 4 from our unit circle is the square root of 2 over 2. So you see this one, you could have just canceled them out. However, for letter B, we're still in cosine, but now it's the inverse cosine of the cosine of 5 pi over 3. Well, what's the cosine of 5 pi over 3? So we have the arc cosine. Cosine of 5 pi over 3 is positive 1/2. Okay, so now when is cosine equal to 1/2? Yes, cosine is equal to 1/2 at 5 pi over 3, but that is not within our restrictions for inverse cosine. So we have to stay in quadrant 1 and say, okay, this is going to be 1 pi over 3, because that still has a cosine value of 1/2. However, it is now also within our restrictions. So then letter C, the same idea is happening where we have the arc sine or inverse sine of sine of 5 pi over 3. 5 pi over 3 is outside the restrictions for sine. So this is going to be the arc sine of the sine of 5 pi over 3 is the negative square root of 3 over 2. That came from the unit circle. So when is cosine negative square root of 3 over 2? You say, well, 5 pi over 3 But again, that's outside the restrictions. And then you say, well, how do I get, let's just draw this real quick so I can explain. Okay, right here, that's where 5 pi over 3 is. And we say, well, if we can't go, let's see, well, if we can't use 5 pi over 3, how do I do that? Well, we use the negative angle. So that's going to be negative pi over 3. And negative pi over 3 does fit within our restrictions of the inverse sine. So this is going to be equal to negative pi over 3. Now D, we cannot take the inverse sine of this because that value is bigger than our domain. It falls outside of it. Pi over 2 is about 1.57. But remember, the domain of inverse sine is negative 1 comma 1. So this does not exist. 1.7 is outside the domain. So that's why I'm suggesting at times that you don't want to always just cancel things, because it is, if you're outside the domain, then you're going to get the wrong answer, like in letter D. Now, letter E, the tangent of the arctangent of 35. So on our calculator, if we do the inverse tangent of 35, we get 1.5422. So it becomes a tangent of 1.5422. Okay, those things were equal. So then in the calculator now, I'm going to type in the tangent of 1.5422. So we would round that up to 35. So this one, it did end up canceling off, because remember up here, the domain of inverse tangent is negative infinity comma infinity. We can substitute any value in for that. But now here we have the arctangent, so the inverse tangent of the tangent of 11 pi over 6. Again, we can't just cancel off that and say it's going to be 11 pi over 6 necessarily. So it's going to be the arctangent, and the tangent of 11 pi over 6 is the negative square root of 3 over 3 coming from the unit circle. Well, when is tangent equal to the negative square root of 3 over 3? And that's going to be, same idea up here when we were talking about the inverse sine. Inverse tangent is in these two quadrants, so we have to use a negative angle. So it's going to be negative pi over 6. Right, so I know that working with the inverses is going to be a little bit of work. It's going to be confusing at first, but having that unit circle just like maybe next to you will maybe help with some of these problems at first, so you can really understand those negative angles. So that's it for today. Thanks for watching. Make sure to like and subscribe.